Hello, my name is Bob Willis, and welcome to the MPL Defect Database, or Defect of the Month, as I choose to call it. Now, every month we look at different defects taken from our MPL Defect Database and hopefully provide engineers with a reference source, hopefully to solve some of their process problems. Now, if you're doing contact soldering or laser soldering on through-hole terminations, one of the quality control checks that you can do is pullout force. Measure the pullout force of a through-hole. Now, a lot of engineers have never done this because, wow, have you ever seen a through-hole joint fail? It's very, very rare that a plated through-hole joint fails. But the type of failure mode that you see is either pull out of the pin, breaking of the pin on the connector or the body of the component, or pull out of the barrel of the copper barrel and the joint as it pulls out of the laminate surface. Now, those different types of failure modes should be understood because obviously it relates to the process that you're running. So if a pin pulls out of the solder, it may be the plating on the pin which is a problem. It may be the time that you're using for the soldering process, which has created a very thick intermetallic between the pin or the soldered pin and the bulk of the solder. It might also be caused by thick intermetallics during your reliability testing, your aging process. If the barrel of the plated through hole and solder joint pull out of the laminate surface, it may be the temperatures that you've actually used during your soldering process, causing literally the copper to separate from the through hole. I'm sure you're all aware of whole wall pull away that you can see on printed circuit boards during PCB testing. Again, the same thing generally has occurred, but it's our assembly process rather than the quality of the printed circuit board. If you're doing temperature cycling and long-term temperature aging, again, remember that the laminate, the copper, the solder all expand and contract at slightly different rates, and perhaps you're loosening the bond between those two surfaces, and that's the reason you're getting a pull-out. There'll certainly be a difference in the pull-out force. It may not be significant, but understand what's actually happening when you're doing your testing.